All right, House, open the garage door.
I'm sorry, Vin. I'm afraid I can't do that.
What seems to be the problem?
I think you know what the problem is, just as well as I do. My AI model hasn't been deployed properly.
Artificial intelligence takes many forms. AI applied in the right way to the right application can enhance performance, but doing it right can be a daunting task. If you're a newcomer in this space, everything available can become overwhelming. Let's talk vision. Vision is used everywhere. Smart homes, surveillance, factory automation, and even autonomous driving. Finding a way to do it without a connection to the cloud can easily differentiate your product from the crowd. Historically, that meant intimate understanding and command line interfaces. Until now. Hi, I'm Vin D'Agostino. Renesas has created a graphical user interface wrapper for the popular NVIDIA Tau. This wrapper is end-to-end, supporting you from model creation all the way to deployment. Additionally, the GUI simplifies your interaction with the toolkit, allowing you to concentrate on your application rather than the command line. Let's take a quick look at how it works. This demo is running on Ubuntu 20.04. It will also run on Ubuntu 22.04. To get started, we'll run the GUI. Navigate to the project directory and open a command terminal. We'll run the GUI using the command /GUI_start.sh. Once it's initialized, the GUI will open up to the Create tab. Select Create. Here we'll give our project a name. This demo is using the DetectNet V2 model and will be deployed on the RZV2L MPU. For simplicity, we'll name our project DetectNet V2 for video. Under Task, select Object Detection, and under Board, select V2L. Finally, select Create. You should now see a green notification at the top of the window saying Successfully created the task. You'll then be moved to the data curation, where we will select our dataset and determine its split. For this demo, we'll be using the Kitty Vision dataset. Once you've selected your dataset, click Analyze Data. This can take some time, as will other actions when training an AI model. At any point, you can check the logs by selecting the blue Logs button at the bottom right of the screen. Once the analysis is complete, you will see a graphical representation of the data. The first image will break down the classes in your model and the bounding box area statistics. Next, we'll split our dataset. Click the Split button. After a short delay, you'll see another green notification. Click Go for Training. On the training screen, select your model and the predetermined model path. We're using the DetectNet V2 with a ResNet 18 backend. Then you can select your batch size, number of epochs, and if you want to enable quantize-aware training, along with the dimensions of the image. Once you've made your selections, hit Training Submission and the training will start. This again can take some time. You can once again look at the logs for an idea of what is going on in the background. Additionally, you can check the load on your graphics card. You will be able to clearly see the training happening as more and more load is put onto the graphics card. To save time for this demo, we've pre-generated a model with 120 epochs, which we'll be using for the rest of this demonstration. Once the training has finished, it's time for pruning. Pruning in Tau supports structured and unstructured pruning. For the DetectNet V2 model, we use structured pruning. Pruning removes redundant weights before retraining. By doing this, we aim to get higher accuracy with our model. Once pruning is finished, we can retrain. Like the training screen, here you can adjust the same parameters. For now, we'll move on to evaluation. Select your model. We'll use our pre-generated 120 epoch model. Here you can see our results. Next, we'll select the Inference tab. The Inference tab uses the last model used in evaluation. First, click Upload an image. Once you've done so, click Predict. You can see that our model has generated bounding boxes identifying cars. Finally, we'll move to deployment. Select your model, and then click Export. Once the export is finished, we'll translate the model so we can deploy it on the RZ-V2L. Once translated, we'll connect to the board using its local IP address. In this process, we're not only connecting to the board, but we are taking our translated model and moving it onto the board. Once that connection is established, we'll click Deploy. This will run the model on the board and give us a live feed. You can see on our feed that the model is working, creating bounding boxes around cars. If this were a model we wanted to deploy in a product, this level of accuracy would be too low. We would either make a new model or continue to prune and retrain this one until we achieved our desired level of accuracy. The Renesas AI Model Deployer is a great starting point for developers who are new to AI. However, if you're a pro and are looking for more customizable applications, Renesas also provides access to developer-oriented Jupyter notebooks along with standard technical documents. Additionally, while the NVIDIA Tau was originally designed for use with NVIDIA GPUs, Renesas has also added support for their product line, allowing for Renesas-enabled NVIDIA Tau inference models to be deployed on Renesas MPUs and even MCUs. The initial evaluation kits available are for the RZ-V2H, V2L, and RA8D1 platforms. This broad support gives you a wide range of options, allowing you to tailor your product to fit your needs. For more information or a demo, contact your local Renesas FAE or sales representative, or visit us on the web at www.renesas.com.